Hi there. So this is a direct continuation from our first video. Okay, so now we need to turn our solution into an iterative method. How we are going to do that is we are going to queue all the nodes that we want to check. Then we do so by using the adjacency list directly. So let's go back to our paper and then write the step carefully. Again, this is problem 207, course schedule. So let's say I have a 0, pointer 1, 1 with a pointer 2 and 3. Actually, the issue is different. The issue that I encounter is basically because there are two cores. Okay, how about this? We have 0 point to 1, and also it points to 2. And then 2, 1 and 2 point to cos 3. Then this is how we got it wrong, basically. Yep. So basically, in our previous attempt for the iterative, we start with 0, we move to 1, and then move to 2, move to 3. So when we first 0 moves to 1, and then we check the 3, check the 4. At this point, we have visited 3 as visited, but we haven't added to check, right? So when we check 2, we see that 3 is visited. That's when we set it to false. Alright, so what do we need to do here? What we need is that when we first check 0, we have 1 and 2. So first of all, how about we pop 1 up? And then now we check 1. And then as we check 1, we pop out 3. And then let's see if 3 is good, then 1 is good. But doesn't mean that 0 is good yet. However, we can check that 3 is good. So when we pop out 3, how about we use a Q to do? And then there is a okay, so we pop out items from the right. How about that? Yeah, I think that could work. So how about 0? And then later on, we pop out 1, so 0, that's 1 and 2, 1 has 3, 2 has 3, 3 has 4. Okay, now we pop 1, now it becomes 2. Sorry, okay, I got it wrong then. Okay, let's do it this way. So 0, I pop 1, and then I add 1 to the to-do, which has 3. And then I add 3. When I pop up 3, can I mark it as good? Well, actually not yet. But I can pop up. Then I add 3 to that. So when I add 3, there is 4. So I pop up 4. And 4 is good. So when I add 4, there is empty. So 4 is good. So I pop it up. So 4 is empty. And then 3 is now empty, so it is good. I can pop up and delete them. 1 is also good, so we delete them. Now 2. When I check 2, I add that there is a 3. Do I add 3 to it? So 3 is now empty. Now I can delete it. Then 2 can also be deleted now. And so 0 can be deleted because it's good. Alright. This is looking pretty good, I would say. How about 3 is not okay? So let's say we have 0, 0.1, 0.2, 0.3, 0.4. and therefore it points to 3. So what are we gonna have? 0, again 1, 2. We add 1 there, 1 points to 3, delete 3. Now we see 3, we add it to 2. 3 has 4. 4 we add the to 3. Now we see that 3 is already in the to-do. So do we just delete them and then mark it as bad? Yes, I think so. Yeah, so we just use a separate adjacency list. Or can we do it directly and then you surface it? Okay, let's go back to the first example there. When we have 3, and then we check 2. Okay, so we have deleted first. Let's see. Okay, I think I got some idea now. So our to-do okay, so that is DFS. Yeah, so what you're doing now is a correct DFS. Okay, next, now go back to our implementation there and see what we need to do now. Actually, let me just do it from the beginning so that we have a clear perspective on what to do. So here, I'm gonna create again a course dictionary. Then for pre, for next, comma current in pre, in current, not in course, then course of cur equals stack, then course cur the append the next. No, and it had to do. To do is gonna start with empty that. and I need to, at the end, I want to achieve is the course is empty. So while course so let's just use it for occur in course if occur not in course, then we can continue. Otherwise, we added our to do dot add code. Then another loop while to do. Here we are going to check if to do of -1. So it should be course. Actually, um, now we got to do. And what we want is we append the last item of it. Of the next. So next is the course. Before that, let's call curve to do the -1. So course of curve of 0. Then actually in the beginning, if before we add the curve, before we add the next, we need to check if it is empty or not. If course of curve, so if not course of curve, then you can delete it from the to-do. To-do dot pop. So is it pop left or pop right? Python that pop right. Okay, so it's pop on the right. Then we continue. Otherwise, we check the next, and then if next is not in the course, then we can pop it too. So course of curl dot pop. Otherwise, we add it to our to do dot append the next. Yeah. And then before we add to the next, we need to check before we add to do, we need to see if it is existing or not. If next in to do, then return false. Otherwise, at the end we return true. Okay, now let's try with our example. Actually, let me go through the code again to make sure I don't miss anything. First of all, I built the course dictionary, which is an adjacency list to all the next courses that I need to take given the current one. And then I'm gonna look through all the courses in the adjacency list. I will add the to-do. If it is not in the course, then I can continue because I assume it is good now. So to do while to do, curl is the last to do. So this is, we need to take the last one so that this simulate the DFS. If the course list is empty, then we can pop it out. From, actually it's not the to do, right? Yeah, so we pop it from the course inside of the to do. So if the next course is empty, then I just pop it. Because there is no need to be there. There is no more next step. There is no more next course to take. So I pop it, then I continue. And then the next time I check to do, okay, my ordering may be wrong here. So curl to do, the next curl is to do 0. If the next is empty, if the course of curl is empty, then I can pop it out. But how about the to do? So I need to pop it from the to do, but where do I do that? Okay, so I need to pop it from course and to do at the same time. Actually, no. So before that, before I check the curl is in core, if it is empty or not, I need to check if it even in the course. If curl not in, so if curl not in course, then I just pop it from to do. To do the pop. Can I just directly pop it there? Yeah, I think so. I can pop it. Curl equals to do dot pop. Wait, why it has multiple type? No, -1. I need to keep this. If curl not in course, then do dot pop. Okay, so I think this could work now. So while to do has something, then I'm gonna check the last item. So if the last item is not even in the course, then I will pop it out. Otherwise, if the list is now empty, I mean the adjacency list is empty, then I'm gonna pop it from the course. Don't forget to continue. Otherwise, if the next is not in course, otherwise I get the next. If next is not in the course, then I pop it out. If next is in to do, then I return false. At the end, I'm gonna add it to our to do. Now let me go to the example again to make sure we got everything right. So far we have 0, 0 has 1 and 2. We append 1 to do. We have 3, so we append 3. We have 4. Now 4 is not even there, so we can pop it out. pop it out from 3. And then after we pop it out, we can continue. Actually, I think we could do better than that. But let me just directly work on the LeetCode here instead of rewriting on paper. So course equals to for next comma current in prerequisites if curve not in course. I'm gonna edit that. Course of curve equals text, and then I'm gonna add next interval width. So dot append next, and then to do is an empty tag, while to do actually I look through it for curve in course. Curve in course. Then we return. Actually, this would be a range of non-courses. I think, yeah, this would be fine if I do it that way. This one will continue. Otherwise, to do the add curve. While to do curve is the last one to do. I'm gonna check if curve is not in the course. Then I'm gonna pop it out. Curve dot hold on. I think there is no way that it's not in the course. So here I'm gonna check. Next is the course of curve of the last one. Actually, it doesn't matter. It doesn't have to be the last one. So let's see. I think I can take the 0. If that's not in course, then I can pop it up. Course curve dot pop left. is length of curve equals 0, that means that the next course after the current one is empty, then I can remove it from our course list. So course dot pop curve. After we pop it from curve, I can pop it from to do as well. To do dot pop curve. Otherwise, I need to append the next into our to do dot append. But before that, I need to check if it is in there. If next in to do, return false. Otherwise, at the end, I'm gonna return true. Okay. That has no add because it's called append. Pop takes no argument. Correct. Key error 1. So I have popped it out. Then I just continue from here. Okay, so this has to be fixed. Can it just be closed? I think no. No, it can. Fine, it works. So let's try to submit it. Hopefully we got this right. And yes, but it's still slow, surprisingly. What do we do wrong? How would I use a listing? Is it because of that? Still slow. Don't understand. Memory is pretty good. How about to do? We use a string list. try this. Yes, I can't get a fast solution even if I do it iteratively. So there must be some other trick here. I think we just type it directly here. Doesn't matter. Cross then I continue. So I try to optimize it here. So I made some changes here and there. Maybe. Yeah, okay. I need to look at some other solution. How do I do that? Okay, adjacency list in degree. In degree of current -1. So it creates Q. Then the current, check the in degree. If in degree of current is 0, okay, so you make use of another variable to keep track of the in degree. So in degree minus 1, if in degree is 0, q.append. So it keeps on removing the top courses that it needs to take, and then keeps on removing until at one point the length of result equals number of courses. I see. So how does it handle a loop then? I see. So here it will not remove a loop. Okay. Yeah, I got it. Okay. So instead of starting at a random point, we could make use of the in degree, and then we start from there instead. Okay, so that is the new concept to me. Alright, so I think I will stop here, everyone. This would be the second attempt, or I would say the third attempt if you like it. Thank you.